Morning, guys. Today we're going to take a closer look at a topic that we've looked at previously and that you've probably seen in pre-algebra, and that's how to calculate perimeter and area in the coordinate plane. First things first, which document are we looking at? We're working off the one called Additional Topic, Area and Perimeter of Composite Shapes. All right? Now, perimeter means walking around a figure. For example, my board right here is a rectangle, and to find the perimeter, I would just find the length of each side and add them up. Area, by contrast, is how much 2D space it covers. So the area of this rectangle would be found by multiplying base times height, or I could say length times width, okay? Now, in geometry, we're going to be using the Pythagorean Theorem a lot of times to calculate side lengths, and we're going to be using area formulas of rectangles and triangles quite frequently in order to find the area of composite shapes that are built of rectangles and triangles, okay? Now, in order to see the method behind this, we're going to take a look together at two examples. The first one we're going to take a look at is example number 3, okay? They ask us to calculate the perimeter and area of a parallelogram. All right. So let's see how this is going to work, okay? Step 1 is to graph the figure. So -2, 3. Then I have 6, 3. 1, 2, 3, 4, 5, 6. Okay. Then I have 3, -1. 3, -1. And I also have -5, -1. So 3, 4, 5. Alrighty. So, couple things here, guys. Okay, let's talk about perimeter first. We said that perimeter meant walking around the edge of a figure, the outside, finding each of the side lengths and adding them up. My first question to you is, how many side lengths do we automatically know here without doing any work? Well, we actually know 2 out of the 4. The reason I know 2 out of the 4 is because they're flat, right? They're horizontal, which means I can just count and I can find their length. So let's find those lengths, guys. 1, 2, 3, 4, 5, 6, 7, 8. And over here, 1, 2, 3, 4, 5, 6, 7, 8. And that makes sense, right? Because we know that parallelograms happen to have 2 pair of opposite concurrent sides. Now the trouble is, how do we find the slanted sides? If you remember from earlier in Unit 1, we saw that the slanted sides were found by using the Pythagorean Theorem. What exactly am I doing right now, guys? All I'm doing is I'm just drawing right triangles in the corners for the slanted sides. This right here is 3. This is 1, 2, 3, I think it's 4, if memory serves me correctly. Let's see, 1, 2, 3, that's 4. And I think that this right here should be 1, 2, 3. All right? So, with that being said, I believe that we have enough information using Pythagorean Theorem to find those side lengths. Let's go. So I've got a squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. Rad 25 equals c, which means that each one of those sides is actually just 5. Okay, so if I want to find the perimeter then, all I gotta do is add up the side lengths. So I could say that my perimeter is 5 plus 8 plus 8, 10, 16, and that means my perimeter is 26 units. All right, so for this particular example, it wasn't that bad at all. A little bit of Pythagorean Theorem to find the slanted side lengths, but for the flat ones, I was able to just count. Now, let's take a look together at how to find area. All right, finding area is a little tiny bit more complex, and we'll talk about that in a second. Although some people might argue it's less complex. In order to find area, we have to make some choices. We know certain area formulas that we can use directly if it happens to be a simple shape like this one. If it's a more complex shape, we may wish instead to break up a figure into smaller shapes find their areas and add them up. In this particular case, let's think about what the best method is. They've already told us it's a parallelogram, and I happen to know something very nice about parallelograms. The area of a parallelogram is defined as the base times the height. Well, look at this. I've actually already got the base here of 8. The height goes straight from the top to the bottom. So count how high that is. 1, 2, 3, 4. So guess what, guys? In this particular case, the easiest method is simply to find the area using the area formula for a parallelogram. Now that worked in this example because the figure was simple, okay? In the next video, we're going to take a look at an example where instead of using one simple formula, you may have to split the shape up and use multiple formulas and then add them together to find the total area.